We'll give another couple of minutes for the people to join. Okay, it will go ahead. So welcome back everyone after a series of sessions. Now it's as a moderator, it is my pleasure to introduce our next session titled Discover the Full Potential of Python Match Case. So the Python Match Case, even for me, it's like I'm waiting to get it from Chamath. So it's like everyone was from the other languages, so they were waiting for Python's match case. So as we all know, and also let me introduce Chamath first. So Chamath is a software engineer at doWhile Group in Sweden with over 7 years of experience in Python. He has a special interest in web development, data structures, algorithms, software architecture, and clean coding. So Chamath was also an organizer in PyCon Sri Lanka 2022. I'm happy to have him back. Just to brief about the topic for today. So we have always wondered why there is no switch case statement in Python and search for an alternative. So with today's session, Chamath is ready to explore with us with the new release of Python 3.10, the match case feature was introduced, which is often overlooked. Many of us tried to use it as simple replacement to switch case statement in other languages, but it has much more potential than that. So let's explore it together with Chamath, and Chamath has more exposure than us. So let's connect with and please join with me or welcoming Chamath Ranasinghe to enlighten us about the full potential of Python match case. After the session, we will have Q&A sessions. So please feel free to ask your questions you may have. Enjoy the talk. Yes, stage is yours.
All right then. So thank you, Asif. So that warm welcome. And so let's discover the full potential of Python. So first of all, hello, I'm Chamath Ranasinghe. So as Asif mentioned, I'm working as a software consultant for doWhile consultations, and my team is responsible for we are working closely with Volvo Cars Corporation for developing some tools for Volvo Cars Corporations in Sweden here. And like Asif mentioned, I was a member of the team who initiated the Python last year in 2022. And last year I was an organizer, but this year I was able to contribute as a speaker. So I'm really glad to be here. So welcome all for my session. And without further ado, let's go into the agenda today. So we'll have a quick look into the match case, like what is match case, what's the basic structure of the match case, and we'll look into that in upcoming slides. And after that, we will jump into the code, and we will look into how we can use match case patterns, like advanced patterns to use in our programs. And after that, let's discuss about potential use cases of this match case and key takeaways after the session. And then you will have time to question, and also feel free to ask any questions in the chat. So I'll try to answer them as soon as possible when I see them. So what is Python match case? Python match case is introduced like this kind of a little bit of history. So it is introduced to Python with Python 3.10. It is
Excuse me,
here
Chamath, I
because of
think
this.
your
Yep.
presentation, I can't see your presentation also. Can you
Right.
please
Sorry.
click on
Sorry. What happened there? Sorry about that.
Oh,
Didn't you see anything? Oh. Okay.
okay.
Can you see me now?
Yeah, it's perfect.
Oh, right. So sorry about that. Technical difficulties. What to do? This is a presentation. So let's talk about the Python match case history a bit again, because you didn't see that. So Python 3.10 get this match case with the Python enhancement proposal like 622, and it's designed to match complex patterns in data structures, I would say. And you can find a bit more information and complex informations like advanced usages from the PEP 636. It has a nice guide and a tutorial about this structure pattern matching. So what is the basic structure of the match case? So it's very similar. It's a very simple but very similar to the switch cases in other languages like Java or C, but it has much more potential, and it can be used to match more advanced patterns. So here we have match keyword, case keyword, and for the match keyword, we can have a subject. This subject can be like a string literal, integer literal, or we can have a sequence there, like a tuple list, or of course we can have like objects there too, and we can have dictionaries there as subject. So in the patterns, we can match those dictionaries using different keywords in Python. So we'll dig into that more later. But let's get to the most basic example of match case. So if you read about the match case previously, you will definitely see this sample code, because it's the most famous one. So here, what happens is we have a status code variable, and it can be integer. And in each case, what we do is like we will match whether it's a 200, is it equal to 200, is it equal to 404, or it's 500. But it is pretty similar to if-elif statement, right? That's right. We don't have any difference in that, because if we talk about like programming languages like C or Java, when we're using a switch case, we have a performance benefit over using if-else statement. Because in C, we have something called jump tables. Jump tables are kind of like when we matching, when program match a pattern, it will directly jump into that byte without comparing other cases or other patterns. But with match case in Python, we don't have that advantage. What we will do is like pretty much similar to if-else statement. We will go each and every case statement and check the pattern. So why do we need match case then? Because we can do the same thing in if-else statement too. We will talk about that in the next slide. And there's a frequently asked question about this match case, because match case introduced like 1.5 years ago with Python 3.10. And at that time, we have match and case keywords used as variable names in our programs, right? So if we upgrade to Python 3.10, will it break our existing code base? So to answer that, so simple answer for that is like no, it won't break, because with match case statements with this new proposal, they are going to introduce soft keywords. So soft keyword is like something like, as an example, if-else keyword. In if-else keyword, we can't use those keywords in variable names, right? But match and case variable names can be used anywhere in the code, but we can't use it in this pattern, like in this structure, you can't have a match variable and a subject and a colon. So this specific for this specific pattern, it will be a keyword. So that's why we calling it as a soft keyword. It also goes to the case keyword, and there are a few other keywords that we are going to use as soft keywords here. So let's try how we can use advanced pattern matching with match case div. Right, it's time for coding. Let's dive into the IDE. Let's see. Can I? Yep, I found it. I think you can see it. This very simple example that we have here, like I showed in the presentation, we have the variable and we have the case statements, and we are matching in order. Let's write. It will work without any problem. So yeah. So what happens is it get the variable name and it go through the each and every case statement, and it found the match and it will print this statement. So nothing fancy, right? But so in actual programs, what happens like this stress code is like a response from a server, right? You can have REST API response like 200 or 500 or 404. So in those cases, 404 and 500 are like pretty much errors, right? So only 200 is the valid or the success stress code, or all the 200 errors, 200 status codes. So in that case, we need to identify all the error codes, not differentiate the 400 and 500. To do that, we have a O statement here. What we can do is we can use this pipe symbol, and we can have 500 here. And now what it does is like it will match 404 or 500 in same this case. Let's try that out, and it's a success. If we try with the 404, it's an error. So it's getting kind of interesting, right? So let's see what else we can do. I previously told you like we can have string literals too here, right? For string literals, I have a very similar program. Let's try this one out. What this program does is like it have a string value, it's success or error. So it will work as similar to the previous example. And if it's success, the value of the status variable is success, it will print a success status. So again, nothing fancy, but let's dive into more details. Right. There's something especially I need to say here. That's about matching these cases. When matching these cases, what it actually does is for string literals and for number literals, it will use this operator to compare these numbers. And for constant values like false or true or what we call none, it will use is operator. So that's what Python does in the behind the scenes. Right. Then this is pretty much similar to switch case statements, right? So what's the difference between other switch case and match case? It's coming with the name, structure, pattern matching. So what is this code? We have a list here, and we are going to match the list against few patterns. And how it's happening? So I think it's pretty much straightforward. We have match case, and if if every value is equal to this value, it will match the pattern. So these patterns does specifically two things. First thing is it will compare the lengths of the length of the sequence, and it will compare the each and every value of the sequence. So let's try that out. So it triggered this case statement, and that's three values. Yep, it triggered this case statement. Right. Before continuing, let's let's understand few other concept. Another concept in the Python is called unpacking assignments. So here what we do is like if we have a sequence, we can unpack the values in that sequence into the variables, and we can print that values or do whatever we want with that unpacked values. So as I show here, it works like that, right? So what if I told you we can use this kind of pattern matching in match case 2? For those pattern matchings, we are going to use this simple program again. So let's dive into how these patterns work. In the first case, what it does is like it is looking for a sequence which has a length of 2, and first element is 1 and second element is 1. So it will only match those values, right? In the second pattern, what we do is we will look into the like a sequence of 3 values, the length of 3 values, and first element of that sequence is 1, and the last element of that sequence is 1. But in the middle, we can have whatever the value we want. So what is this var? Is it a keyword? No. It is actually a variable name, but they call it as a capture variable, and this variable can access in the case code block. So if we run this program, what happens is it will assign the middle value to this like it not assign actually, it will bind the middle value to this variable, and we can use that in the code. So it's nice, right? So what else we can do? We can use that sequence unpacking here in pattern 2. We have ABC, these are variable names, and what we are going to do is like we are going to match any sequence with a length of 3, and we are going to assign each and like first value to the A, and second value to B, third value to the C. Let's see A value. On match A equals 1. So it's nice, right? So what else we can do here? Like we have these integer values, we can have strings here too. If we have a string value like, let's see, we can have a string value like this. Print customer. That's the sequence, and to string. So when we mention that string, what we are going to do is like, if it is print, we can bind the name to bind the second variable, this second value to the name variable, and we can print it. So what this pattern does is like pretty much similar to the previous example. It will match for the, it will search for the patterns like we have two elements and first element is equal to print. So let's run this one. We have customers string binding to the name variable and it is printed. So after that, what else we can do? For this command subject, I would say, for the match subject, we can have tuples, lists, and dictionaries actually. And we can have class objects. But we can't have iterators. Cannot have. Oh, byte arrays. Or strings. Wait, what? We can't have strings? No. We can have strings, but these strings will not like unpack and we can't match pattern inside the string. So as an example, if we have a string like this, let's say LK, we can't match this A with L. We can't match it like this. We can match it as a string literal, but not as a sequence. So in technical, what we have to have in this match subject is something inherited or use the class what we call collections dot ABC sequence. I think I'm right with this name. Yep. We only can have objects inherited from this class actually for the subject. So let's try again with another example that we can use. Like we have, let's undo these things first. So we can have another command like add customer, maybe, and customer can have a name, maybe name, I don't know. There, what we're going to do is we are going to use that pattern and we are going to cache that pattern and we are going to act accordingly. So it's a customer and we have the name here and it's add the statement. There, what we're going to do, we can save it in a list maybe. Here, customers dot append. Okay. Okay. We can issue another command to print all the customers in the list. This is a very simple like a customer directory, I would say. So we can use customers here. Oh, English is pretty bad, right? We can print all the customers. We don't want this. Okay, what happened? Something. Yep. Name is to my Never mind. Just use my commands that I used previously. We have a command here, and again we have to type the command. Sorry about that, guys. When it's a presentation, we have some technical difficulties like that. We are going to print all the customers there. The list, right? Okay, let's try that again. Mhm. Mhm. Yeah, I'm sorry about that, guys. I don't know what's going on there. Anyway, what it's supposed to do is when we pass this command, it will compare the values here. And when it matches this pattern, we have the first element as ad and the second element as customer. Maybe this is the problem. Then it will bind this animal name into the customer variable, and it should append it to the customer. And when we issue this print command, it will print all the ones here. Let's try it again, maybe. Yep, that was a typo. Sorry. So it's working, right? Then we can add few more names if we need. Maybe polygon. All right, we have customers here. So this, as I told you, is kind of a simple program for the customers register, right? So in that case, we can move it to a CLI application. What we can do with CLI application is to make this a CLI application. We can have something like this. For the beginners, don't worry about these things. So it's a very basic Python, but you don't have to worry about these things at the moment. What it? So I will explain the code again in a bit. Yep. It's not going to be list. It's going to be a str. You need that part. Yep. Let's clear the command line. Okay. What does this program do? It will get a simple input, string input from the command line, and it will pass that input into the run command function. And we are going to split this string command in from the spaces it has, and we are going to match that return tuple into these different types of patterns. So if you need to add a new customer with this program, what we are going to do is we are going to write like add customer, maybe customer, what we call it again. And if you need to print customer, we can call print customers, it will print customers. And if you need to add another customer, let's see Siri, print customer. It has all the names I entered, right? So it get this argument as a string argument, and it pass this whole string into the fun command, and it will split in spaces. We have a space here, and so after this splitting, it will what we call, it will return a tuple like this. So this tuple will be matched against these cases. So that's what happening in the behind scenes. Right. When this kind of a program, when we write this kind of a program, we can expect like few different arguments. Like it's hard to write add keyword each and every time, right? So maybe we need to try with A. If we have A in the first place and customer in the second place, we are going to append the new customer into the customers list. So let's try that one. A customer and little. Sorry about the typo. Print customers. It's matching this pattern, but it's kind of code duplication, right? We are going to append this name into the customers anyway. So instead of doing this, we can do something like this. We can use this O statement, O symbol, and we can add A here. So what this does is it will match in the tuple we have given in the first element. If we have an add or A, it will match this pattern. So let's see. Let's see. A customers. Serial. Customer serial. Yeah, it works. We can have this kind of variables. Right. What else we can do? We can do like, we can have a if statement in the beginning of this case statements. We call it as a guard. So we can have further validations using this if statements, like maybe we only allow few commands, not everyone. Like let's see, have commands like add, maybe we can allow A, maybe we can register. These are pretty much same names, right? So if the operation, the command, the first element in the tuple is one of these values, we are going to match this pattern. To do that, what we are going to do is if OP in commands here, we are going to match that pattern. So what happens here? This OP is a capture variable. It will capture the first element and it will bind it to this variable. And in the if command, what we do is we will get the value of the OP variable and we will check whether that variable, that value is in the command list. So let's see how it works. Let's try with the new one. Register customer. Okay. In customer, yep, it works. It matched this command and it will work accordingly. All right then. Another important thing that we need to keep in mind when we're using these patterns is like it doesn't matter you have a this this parentheses or brackets. You can either have parentheses or what we call you can either have this kind of tuple symbols, or we can have list symbols like these brackets. So it will not make any difference. It will identify everything as a list or a tuple. You can match anything there. Okay. Wow. What else we can do here? I told you. I told you like we can have big objects in the subject of the match, right? So let's try with dict objects then. For do that, we will again look into the very simple code we previously get. It's about a response from a server. So this response is can be a JSON response. In JSON response, we have a dictionary type kind of value format. In there, we may have a status code, right? And its status code can be 200 or 400 or anything integer. And after that, we may have data. That's a keyword, and that keyword will have anything, any value, maybe a string, data string, or another dictionary. Name is okay. Let's pass this dictionary into the match case. Okay, what happened here? You don't have to worry about these things yet. It will match the first pattern because it has the status keyword here, and it has the 200 value, and it has the data keyword here, and we have another capturing variable. It will capture the whole data and it will print out. That's what happened here. Okay. Then we can have like for success status, we can have data or payload value, right? If the dictionary have a payload value, we are going to consider it as data and we will print that out. So let's say it's payload there. It's payload. So it's a payload, right? It might match this pattern. But again, this is kind of redundant, right? So can we use O pattern here? Yes, of course, we can. We can use O pattern to match two different patterns like this. Let's remove this part. Try again. Yep, it works, right? What it does is it will check this pattern or this pattern. If any pattern succeed, it will execute whatever the code inside this pattern. And that's this inside this case. All right. What happens if we have an error status? But in an error status, we are not going to have a data, right? We will have a message maybe. So if it is a error status, we will have a message like this. We are going to print print that message. So error message. We have here response. We are going to run this one. Yep, it's an error message. But we have more than one error status codes, right? In that case, what we can do is we can use if statement here. If status code value is greater than maybe 300 or 400, it's greater than 400, it will decide this as an error message, error response, and it will print error. So we have 500 here. It matches the error case, right? At last, we have a very specific notation here. In normal Python, this underscore is kind of, we can use it for what we call variable names, like this, without any issue. All right, it's working without an issue, right? But in this specific case, it will not work as expected because this is not going to be a normal typical capture variable like status code or message. This is a wildcard in Python match case. So it's very similar to match and case soft keywords. Underscore is a soft keyword too when it comes to the match cases. So what it does is like it will match any value in the response, and it's kind of like the default statement or default or the final statement in the other programming languages, but we can't print that value. This is not going to assign in this value. We can't print that value. If we try to print that value, it will give us an error like this. Name is not defined. It's not defined. So it's this, we call it as a wildcard, and we are only allowed to use that in the last case pattern. Because if we use it in the first case, it won't match any other cases. So it will match the first case and it will ignore all the other cases. All right. After that, we have a very interesting thing that we need to try out. It's regarding type matching actually. When I call it type matching, we are going to match type of the subject or the type of the past any subject or sequence. So here I have introduced the new class. It's called C, and we have created a new variable called A and new object from C class, and we are going to pass that into the match case. And if it's instance of C class, it will match this pattern and print C class form. Let's try that out. Let's clear the terminal first. All right, we have C class form. But do you see this is pretty similar to constructors in Python, right? That's how we are going to create a new object from the class constructor. So is it going to create a new object when calling like this? No, it won't create any objects like this because I will show you. I'll show you it doesn't trigger this init method when it's comparing the comparing init call. So in this case, we should only see init call once because we are going to construct an object here. Yep, init called once, but after that we don't have a init call. So what does this case does is it will try with its instance method to match the pattern. So actually that's what Python does. After that, we have a interesting pattern here. We have a built-in class, right? So this built-in class is integer. So in this case, we can do kind of validations with these built-in classes. Like if you pass a string here, it will not trigger this built-in class, but it will trigger str class, right? We can have a print here. It is str. Yep, we have a str. So with this knowledge, we can improve our previous example like this. This is the previous example that we used. In here, we are only going to match integer variables, right? If we pass a string here, we will not match that value. Let's try that out then. We have maybe success here. It didn't match this case. It only matched integer values here. All right. There. We have some interesting for the example here. We are going to use this type matching with we are going to use some advanced type matching with the classes. As I said before, this is very similar to constructing a new object, but we are not going to construct an object, but we are going to compare the values of the object instead. Let's try creating a new point. We are going to create this point called A. You can think this program as this uh, this point is some point in a Cartesian row, like a Cartesian table. We can have 1 or 1 and 1 and 0. So it will construct a line, I would say. So we are going to identify the type of this point. So to construct this point, we are going to use 1 and row. So this point is in the Cartesian plane, like in the y-axis, and the x value will be 1. So we are going to match that. Where is point A? So in this case, what should it does is like it takes the value and it goes through each and every case pattern, and it will check whether the first like the x value is equal to 0 or is it any value. So in this case, if we pass 0 here, it will match first pattern. If x is 0 or y is 0, we are going to match this pattern here. Yep, it is matching this origin pattern. And if we need to like x is 0, but we can have any other value here, like 23 maybe. In that case, it will print y23 because it will match for the x value is equal to 0, but we can have any value for the y. And likewise, we can have y value also. We can have y value 0 and any value here. And it matches this pattern. Sorry. So it will match this pattern and it will print x value here. And what happens if we don't specify any values? Like if it does not match in any value we have created, when we pass this point to 35 and 34, it will be match this pattern. So because this A is an instance of point class, if we pass any other value, not a point class value, point class object, it will print not a point. So it's pretty straightforward, right? But we have used attributes like we have used x equals 0 like a keyword assignments to match this pattern. Can we use like positional arguments to assign these values? Yes, of course. What happens is without the keyword, we can match the point. It will identify this data class will identify first value passed is x and second value passed is y. So that's why it's going to work. Let's create this. There is A. It's in the origin. Okay. Let's try something different. Like a normal class, not a data class. We are going to use a normal class for the point. And we have a init method here. Self equal in x maybe. Okay, we have x here. We have y here. Then we're going to assign those variables here. Okay. Create this value. Let's change the name, like to something else, just for the demonstration purposes, because I have something to show you. Y10. I will okay. So in normal classes, we have we can use this kind of assignment, not like data classes. But when we are doing those kind of assignments, we have to use a special argument called match args to define the order of the arguments. First argument will be x and the second argument will be y. So in that case, you can use something like this. Yeah, it is working, right? The previously it didn't work because we didn't have this match argument. Okay, so that's kind of interesting findings about match case, I think. So let's go back to the slideshow. This is a quick recap what we have done so far. We have worked with single and multiple values, and we have used wildcards, and we have used O patterns, and we have used as given, and we have used if guard to match pattern, and we have used objects and building classes. So it's kind of a lot of features for one talk, but it's interesting. So that's why I took all the features here. So potential use cases of this match cases for interactive CLI programs, like we did with this customer registration directory of the program. So, and of course, we can use this match case in linter plugins like Flakegate. There's a very nice talk about using Flakegate and creating a custom plugin in Israel PyCon 2022, I think. If you're interested, you can watch that too. And we can use this for method overloading, and there are some nice example in the internet. And we can, as is so, we can use JSON data mapping to map any response for the server and much more. Right. Key takeaways from this lecture. In my opinion, this match case does not introduce new functionality with something that we can't do with the existing keywords in the Python, but it will like vastly simplify the complex patterns, and it will like reduce the complexities, and it will improve the readability of the pattern. Again, I encourage you to read the PEP files whenever you can, because it has a lot more detail than all the other videos or all the other lectures or the tutorials out there in the internet. So when you have time, please refer the PEP files so you can get a much more understanding about the features. Okay, it's time for questions. So
thank you, Chamath. We have only few minutes left, so if you have any questions, please ask them in the Q&A section. If you don't have any questions, we'll have to wrap this up. Thank you, Chamath, for the very interesting and very practical session. We have the closing keynote starting at 4 p.m. So if you are interested, all of you can join the closing keynote. Thank you again, Chamath. We hope to see you in our next PyCon also. Okay, bye.